The Sun is a burning bright star in the centre of our solar system. The Sun was born about 4.6 billion years ago. It is so big that it can fit 1.3 million Earths inside its sphere. The Sun provides us with light, heat and energy. The Sun is 149.6 million kilometers from Earth. Earth is the right distance away from the Sun to support life. If the Earth was closer to the Sun, people would burn, or if it was further, people would freeze. To fully understand how the Sun works, we have to go deep inside the Sun. The Sun is a big ball of hot gases. Inside the Sun's core, these gases are converted into energy. The energy passes through the interior layers and into the Sun's atmosphere, and is released as heat and light into our solar system. About 70% of this gas is hydrogen, and 28% is helium. Carbon, nitrogen and oxygen make up 1.5%, and the other 0.5% is made up of small amounts of other elements such as neon, iron, silicon, magnesium and sulfur. The Sun is like a big nuclear submarine in the sky. It is fueled by nuclear reactions that fuse hydrogen atoms together into helium and other heavy elements, releasing huge amounts of energy in the process. It converts the mass into energy slowly in the form of sunlight. It is more than enough fuel to last billions of years. Well, 5 billion to be exact. Most of the Sun is actually made of protons. The protons repel from each other because of the electric field. They are positively charged. The Sun is so hot that the protons are moving quickly and they can't avoid the collision. When the two protons collide, they lose mass. The protons get lighter and the mass it loses is converted into energy. E equals mc squared means energy equals mass speed of light squared. This equation tells us that the mass that comes out is converted into a lot of energy. The speed of light is a huge factor. Small amounts of mass lost is a huge amount of energy. The Sun loses about 4.3 billion kg per second. That amount of mass is converted into energy. In the Sun, hydrogen fuses together to form helium. That's a bit strange as how, out of all protons, we create a helium nucleus which has 2 protons and 2 neutrons. When 2 protons collide, one of the protons actually emits a positron and a neutrino, and it quickly becomes a neutron. The next thing that happens is that another proton comes smashing in, where more energy is released. If 2 particles like this collide, they emit 2 protons, and what we are left with is a helium-4 nucleus. There you have a hydrogen fused into helium. A lot of mass lost, a lot of energy released.